Next 5 minutes or so, I shall be talking about importance of water in concrete. The water cement ratio is the ratio of the weight of water to the weight of cement used in a concrete mix and has an important influence on the quality of concrete produced. A lower water cement ratio leads to higher strength and durability, but may make the mix more difficult to place. Placement difficulties can be resolved by using plasticizer or superplasticizer. Before we proceed, let's understand the water cement reaction. Concrete achieves its strength through a chemical process called hydration. Hydration is a complex process, but in simple terms is the reaction between water and the cement in the mix. With help of this diagram, let's further elaborate it. In stage 1, hydrolysis of the cement compound occurs rapidly with a temperature increase of several degrees. In stage 2, known as dormancy period, the evolution of heat slows down dramatically in this stage. This can last from 1 to 3 hours. Here, concrete is in a plastic state which allows it to transport and place without major difficulty. At the end of this stage, initial setting begins. In stage 3 and 4, the concrete starts to harden and the heat evolution increases, primarily due to the hydration of tricalcium silicate. Stage 5 is reached after 36 hours. The slow formation of hydrate products occurs and continues as long as water and unhydrated silicates are present. There are different types of water like municipal water, well water, recycled water, etc. Now let's understand the requirement of water used in concrete. Water is required for workability and lubrication, and this additional water should be minimum. Silt, oil, acid, alkali, organic matter, sewage, chemical, industrial waste, etc. will have a bad effect on concrete. Water with less than 2000 parts per million of total dissolved solids is satisfactory for making concrete. Water with more than 2000 parts per million of dissolved solids should be tested for its effect on strength and time of setting. Water used for mixing and curing shall be clean and free from injurious amounts of oils, acids, alkalis, salts, sugar, organic materials. Potable water is generally considered satisfactory for mixing concrete. Mixing and curing with seawater shall not be permitted. The pH value shall not be less than 6. A popular thought is that the water fit for drinking is fit for making concrete, but this may not be true statement for all conditions. Some water containing a small amount of sugar would be suitable for drinking but not for making concrete, and water fit for making concrete may not be fit for drinking. If water is not obtained from satisfactory source, then the strength of concrete made with questionable water should be compared with similar concrete made with pure water. The best course to find out whether a particular source of water is suitable for making concrete or not is to compare its 7-day and 28-day strength with cube made with distilled water, and if the compressive strength is up to 90%, the source of water is accepted. Having understood the requirements of water used in concrete, let's understand the effects of impurities in water. If dissolved salts are present, it reduces compressive strength by 10 to 30%. Then, from another source, if the difference in compressive strength is less than 10%, then that source of water is permissible. Large quantity of chlorides causes dampness, surface efflorescence, corrosion of steel. Industrial wastewater containing acid or alkalis are unsuitable in terms of pH value. The water that has a pH value between 6 to 8 can be employed for the concrete construction. The sugar contained in water, if is less than 0.05% by weight of water, then no adverse effect is observed in the concrete structure. The sugar content in 0.15% will result in retarding of setting time and the early strength of the concrete, but it is observed that the 28-day strength of concrete is improved. The sugar content increased by an amount of 0.2% is said to improve the setting time. Further increase of sugar will cause rapid setting, but the 28-day setting is affected. Oil in water. Water that have no animal or vegetable oil content have no adverse effect on the concrete properties. The mineral oil content to a percentage of 2% is said to increase the strength of the concrete, but for more than 8% mineral oil, the strength is reduced. The vegetable oil in water used for concrete manufacture shows its detrimental effects on the strength of concrete at its later stage. Ladies and gentlemen, with this I have come to an end of this video. Thanks. Jai Hind.